Hello everyone. Today we will be learning if-else in Verilog. If-else is a conditional statement because here the statements are evaluated based on some condition. Means the statements are evaluated and executed when the condition satisfies. And this if-else generally enforce a multiplexer in digital logic. Means if you write if-else in your Verilog code, then your simulator, it considers it as a multiplexer. Means it is converted into a real hardware, a piece of real hardware that is a multiplexer. Okay, means this one. So this is the syntax. First one, if, then some expression, then statement. Here there is no else, so this is one kind. Another kind is if, then parenthesis, expression, then some statement, then else, some statement. Means if this expression satisfies, then this statement is evaluated, else this statement is evaluated. This is second one, second type. And the third one is nested if, means if, else, if. Okay, so there will be some statements here. Okay, there will be some statements. So there are three different ways we can write if and else. Okay, let me explain you what this means, this line means. If else generally enforce a multiplexer in digital logic. Okay, here is a piece of code. If a begin y equal to x1. Okay, this is a Verilog code. So what does it mean? So how your simulator or your synthesis tool understand this piece of code? Okay, if a begin y equal to x1, else b y equal to x2, else if c y equal to x3, else y equal to x4, and see what it is written here. If else, this if else generally enforce a multiplexer. So when there is a if else condition in your Verilog code, then it is converted into a real hardware, that is a multiplexer. For example, if a is true, then y equal to x1. So e, this is select line, a, b and c, these are the selects line. Okay, so if a equal to 1, then this is 1, right? So y equal to x1, so y equal to x1. Else means a equal to 0. Now the condition satisfy a equal to, if a equal to 0, then this line, this data will be propagated to y1. So y will be x2, so y will be x2, but at the same time b equal to 1. So if b equal to 1 and a equal to 0, so b equal to 1 means this x2 will propagated to output. At the same time a has to be 0, because if a has to be 0, then only this data will be propagated to y. So else b y equal to x2. Else if c, means here b equal to 0, means here c equal to 1, b equal to 0 and a equal to 0. Okay, then y equal to x3. So c equal to 1 means this data x3 will be propagated to this one, but for this b has to be 0, so b equal to 0, and for this a has to be 0. For this data x3 to be propagated to y, what is the condition? C equal to 1, else c equal to 1, b equal to 0, and a equal to 0. Okay, else y equal to x4, else y equal to, that means c equal to 0, and your y equal to x4. So this is a pure hardware, right? It is a pure combinational circuit. So if else are pure combinational circuits, and it is a multiplexer. Okay, you always remember, if during the interview if they ask what a if else condition enforce, means how it is evaluated by your synthesis tool or your simulator, then the answer is it is a multiplexer. Okay, and it is a combinational circuit. Okay, so this piece of code it consists of 3 multiplexer. Okay, so one example is here. This is a behavioral code for 4:1 mux. Okay, 4:1 mux. So this is the inputs, then output, then always I0. These are the signals, 4 signal, because this is my multiplexer, then this is my out, this is my S, that means this S0 and S1, S0 and S1, and this one is I0, this is I1, this is I2, and this is I3. So if S0 equal to 1, if S0 equal to 1, see, if there is any changes, because it is inside this is always block, this is a procedural block. So if there is any changes in the sensitivity list, I0, I1, I2, I3, S0 or S1, then the statements are evaluated. Okay, so if S0 equal to 1, S0, where is the S0? This one is S0 equal to 1. If S0 equal to 1, then it will again check the condition. If S1 equal to 1, if S1 equal to 1, see, S0 equal to 1 and S1 equal to 1, then I3, out equal to I3, this one, so out equal to I3. If S0 equal to 1 and else, means S1 equal to 0, so else S1 equal to 0, this one, this, then out equal to Y2, then out equal to Y2. If else, means now S0 is not 1, S0 is 0, so S0 is 0 means these two condition. If S0 equal to 0 and S1 equal to 1, this one, S1 equal to 1, then out equal to Y1, out equal to Y1, else out equal to Y0. So this is 4:1 mux and behavioral code for 4:1 mux. Okay, and this is how it works. Okay, and this is a synchronous D flip-flop. This is the code, verilog code for synchronous D flip-flop. Okay, all these codes are working code. Okay, if you want to test this code, you can. So this is a synchronous D flip-flop, clock reset D and Q. So this is a flip-flop. This is my output Q, then this is the D input, then this is my clock, and this is my reset. So inputs are D, clock and reset, and output is Q, and range is also Q, always at the rate passage of clock. So if there is any passage of clock, positive passage means positive edge of clock comes, then what happens? Begin and end, it checks whether reset equal to 1. If reset equal to 1, then Q equal to 1 be 0. So we will get the predefined data, predetermined data, that Q equal to 0. That means we are assigning a known value to our output. Okay, not to have a weird behavior of your circuit. Then if reset equal to 0, then what will happen? Then simply this data, this input data will be propagated to output. Okay, so this is also if and else condition. Here also if and else condition. If so, this is kind of nested. If you can see, you can say if else all these things, but it is also if else condition. So this is how the if and else works. What you have to remember is this if else is nothing but a piece, whenever it is converted into a piece of hardware during the synthesis time. Okay, so how it is handled? It is just a mux. It is a pure combinational circuit and it is just a mux. Okay, so I hope that you guys understood if else in details. And if you liked the content, then please do like, comment and subscribe this channel, and thank you so much for watching.